So in this video, we will talk about the last section of chapter 8, 8.5 in your textbook, which is the hypothesis test for the population standard deviation or the variance. Now, remember from the first section, we talk about the population proportion, that we must use the Z statistic. For the population mean, we use the student T statistic. And now for the standard deviation or variance, we use the chi-square distribution. Remember that if a simple random sample of size n is obtained from a normally distributed population with the mean mu and standard deviation sigma, then we have the formula of this. Okay, S square is a sample variance and has the chi-square distribution again with n-1 degree of freedom. So this is from chapter 7, the chi-square. Now the requirements for the testing hypothesis about the variance or standard deviation is that the sample must be obtained using the simple random sampling, and it is normally distributed. Okay, two conditions. This is easy. Much more simpler comparing to the last two sections. Now, these are the steps for conducting a hypothesis test about the variance or the standard deviation. Again, we have to know the nodes and the alternative hypothesis, because we will decide whether they are in one of these three cases: the two tails, the left tail, or the left side or less than, or the right tail or the greater than the null hypothesis. We also be given the level of significant alpha. This is the seriousness of making the type 1 error. Now the next one is, again, we have to compute the test statistic. In this case, we do the chi-square. The last section we did the T statistic, but this one we use the chi-square, and we have to use the table in the textbook, or I'll give you later, to determine the critical value using the n-1 degrees of freedom. Again, there's three cases: two tails, left tail, the right tail. Now they are a little bit different. They are not symmetric comparing to the last two sections. The left critical value is chi-square of 1 minus alpha over 2, but the right side is chi-square of alpha over 2. Okay. Now this one is for the left tail, which is chi-square of 1 minus alpha, and chi-square of alpha is for the right tail. So alpha over 2 is for the two tail only. The other left and right tail, they only use the alpha. Okay, and these areas are called the critical region. Now, compare the critical value with the test statistic. Once you compute the test statistic here, then you compare this value to this value. If that value, the test statistic, less than this value or bigger than this value here, then we reject. Or for the left tail, if it's less than this statistic here, then we reject. Or it's bigger than for the right tail, then we reject. Or in other words, if the test statistic falls in the critical region, which is one of these areas, right? It's fall in the critical region, then we all reject the null hypothesis. The last section, we compute the p-value, and if the p-value is less than the alpha, then we reject. Now we compute the test statistic, the chi-square, then we compare to the critical value. If it falls in the critical region, then we reject the hypothesis. and after that we state the conclusion. Okay, let's try the first example. Testing a hypothesis of how a population standard deviation